Hello, Algebra 2 people, and welcome to the final video on probability that we're going to do. This time, talking about probability of repeated events. We talked a little bit about repeated events in the last video, but we're going to talk about them a little bit more today, give you a couple different situations to look at. Remember, like the probability of an AND event was the probability of one thing times the probability of the second thing occurring. And the same thing's going to happen here. So if um, if you're given a problem that says like, oh, the probability that it's going to rain today is 25%. So as a decimal, that's 0.25. And if the probability that it's going to rain tomorrow was also 0.25, I could multiply both those together to say, well, what's the probability that it's going to rain on both days? On today and tomorrow. That's an and. And so you can plug that into your calculator and just multiply 0.25 times 0.25 to get 0.0625. And that would be the probability that it rains on both days, today and tomorrow. Okay? So when you're looking at the probability of things happening, you just multiply them all together. But sometimes we're interested in a slightly different probability. And let's say we're rolling some dice. I've got some dice here. Ta-da! Hey, I rolled a 7. But let's not start with 7. Let's start with a simple one like, what's the probability when I roll a couple of dice, or I roll one die twice, would even do the same thing. What's the probability that I come up with a total of 2? And here's a total of 2, 1, 2. Well, when we're looking at this, we have to think, how many different ways can that occur? And I wanted to start with this one combination because there's only really one way that can happen. I have to get a 1 on both of the dice. And so there's only one way for that to occur. Now notice that if I were to roll that die first and then this one, I'd still get 1, 1. So I don't want to count these as separate things. I'm going to count them as just one thing. If they both show 1, that just occurs one way. But what happens when I talk about maybe getting, if I can find it, how many ways can I get a 3? So I roll 2 dice and I get 3 for the total. How many ways can that occur? Well, I have to count how many ways that can occur. And so I say, well, I could get a 2. I could roll a 2 first and then roll a 1, and that gives me 3. But here, there's another possibility. I could have rolled the 1 first and then the 2, and that's also 3. So there's 2 different ways that I could get a total of 3. Let's move on. How many ways can I get a 4? Well, I could roll a 2 and a 2, and really, since they're both 2, the order's not going to matter because they're both got to be 2 to get that. Or I could roll a 1 and a 3. That's also going to give me 4, isn't it? So I have a 2 and a 2, or I could have a 1 and a 3, but wait, I could have had a 3 first and then a 1, and that is a different combination. So I could have had a 1 and a 3, I could have had a 2 and a 2, or I could have had a 3 and a 1. And so that way there's those different ways. How many ways can you do it, right? So if I count those again, I had a 1 and a 3, a 2 and a 2, or a 3 and a 1, different ways of making a 4. So that's 3 different ways that could occur. How many combinations are there? Well, there's 6 different combinations for this die and 6 different combinations for this die. And so if you think about your probability kind of thing, we're going to multiply those together. So we're going to say there's 6 times 6 possible different things that could happen, or there's 36 different combinations. So if I was going to ask the question, how many or what's the probability that you're going to roll a 4 when you're rolling a pair of dice? The probability is 3 over 36, which is 1 out of 12, right? 1/12 when you reduce it. Make sense? Without using the die, let's just use our brains. How many different, or what's the probability that I could roll a 6? So 6 is my target number, and we have to start thinking about how many different ways, how many ways can I roll a 6? Well, I'm going to write some down here. I could roll a 1 and a 5. That's one combination because they had to be 6. I could roll a 2 and then a 4. That's also 6. I could roll a 3 and a 3. That's also 6. Or I could roll a 4 and then a 2. That's also 6. And then I could roll a 5 and then a 1, and that's also 6. So if we count all the ways we could do this, there's 1, 2, 3, 4, 5 different ways that we could get a 6 when rolling and summing them up. So that's 1, 2, 3, 4, 5 out of how many? Still 36, because there's 36 different ways that could happen. You can roll 6 different numbers on the first die, 6 different numbers on the second die, multiply those, get 36. So that's 5/36 is the probability that you could roll a 6. Okay? So somebody's trying to break into my room. Let's take a look at how Manga High presents this stuff and play along one round of this. Starting off on the easy stuff. The probability that I win the computer game Algebra Meltdown is 0.4. What's the probability that I lose? Now you got to stop and think, because the probability that you win plus the probability that you lose has always got to be 1, right? If it was 50% chance that I'd win, it's a 50% chance that I lose. And you take those 1 out of 2s, and you put them together and you get a whole. So if it's 0.4 that you're going to win, it's got to be 0.6 that you're going to lose, because if you added those, you got to get to 1. The formula for 2 independent events, both happening again, is the probability that A is going to happen times the probability that B is going to happen. The probability of 2 independent events are 1/4 and 1/3. What is the probability that they're both going to happen? So we can just multiply to get 1 times 1 over 4 times 3, and 4 times 3 is 12. So that's going to be 1/12. The probability that I'm late for work each day is 2/5. Find the probability that I'm late for work 2 days in a row. Again, so I'm late the first day and I'm late the second day. That's going to be 2/5 times 2/5. So you just multiply 2 times 2 to get 4, and 5 times 5 to get 25. So it's 4/25. The probability that I win the computer game Flower Power, ooh, I love that game, I don't know what it is 0.9. Find the probability that I win 2 games in a row. So if each one's 0.9, I'm just going to take 0.9 times 0.9, and I think that gives me 0.81. I throw a 6-sided die twice, just like we were talking about. One possible outcome is that I throw a 4 and then a 5. How many possible outcomes are there? Well, I'm throwing a 6-sided die twice, so there's 6 possibilities times 6 possibilities, and that's going to give us 36 total possibilities. I roll a die twice. How many ways are there that I can score a 2? And they've got a nice table here, so all we have to do is look for how often 2 occurs inside there. But we already kind of looked at that problem. We said, the only way to score a 2 is that snake eyes thing. You get 1 twice. So there's only one way to do that. It's right there. One possibility. Each time I play the computer game PEMDAS Blaster, you know what PEMDAS is. That's your order of operations. The probability I win is 3/4. Find the probability I win one game, then lose the next. So I got to think about this. Now, the probability that I win is 3/4. And then if the next game I lose, what's the probability that you lose? If the probability that you win is 3/4, the probability you lose is 1/4. So we're going to have to multiply 3/4 times 1/4 here. And that's going to be 3 times 1 is going to be 3, and 4 times 4 is going to be 16. So I think this got to be 3/16. The probability that I win a computer game, or the computer game Ice Ice Maybe, is 1/3. Find the probability that I lose 2 games in a row. So stop and think for a second. If it's 1/3 that I'm going to win, it must be 2/3 that I lose. And what if I lose twice in a row? Well, then I'm going to have to take 2/3 times 2/3. So that's going to give me 4/9. Each time I play the computer game Flower Power, the probability that I win is 3/10. Find the probability I win one game and then lose the next. Again, you got to think, well, if the probability that you win is 3/10, then the probability that you lose is going to be 7/10. So we're going to have to take 3 times 7 to get 21. And 10 times 10 is 100. So I think we're at 21 100ths. If I roll a 6-sided die twice, find the probability that I score exactly 12 with the 2 rolls. Well, how many ways is there to get 12 if you're only rolling twice? 5 and 5 is only 10, so it's not like you can roll 5. You have to roll 6 both times, don't you? And there's only one way to do that. You have to get a 6 the first time, and you have to get a 6 the second time, and there's no other possibilities. So there's one way to do that, and there's 36 different possibilities. So we're going to do that. Okay? All right. Well, we're at the end of the video. That means it must be your turn to try this on Manga High. So go ahead and log in, see if you can get a gold medal on this. I'm pretty sure you can. Have a great week. Weather's nice outside. Don't get shut in the entire day, but enjoy some of the weather, and hopefully we'll be talking to you real soon. Bye-bye.